Okay, so the next function that I would like to show you is the function for drawing off the node schemes. So let's show this function now. If we go to our main workspace, here we have the function for drawing off the node assembly schemes. And like everything in Urbano, you see here different configurations. And just by checking the names of these configurations, you can see them that it depends on different materials of the pipes, different connection types. So is it a socket, double socket, or flanges, and which angles are available in that configuration. So let's see what else can be done with this function. If you right mouse button on the main group, you see that here you can draw valves and hydrants. And these valves are not the valves from EPANET, these hydraulic valves that we talked about yesterday. So basically modeling valves, pressure reducing valve, pressure sustaining valve, pressure breaker valve, and so on. These are we can call them gate valves. So if we open this command here you can see that in this function you can define valves and hydrants that will later be included in the node assembly schemes. So first of all, let's draw valves. For the type of the valve, you can select from the catalog. I will use butterfly valves. You can choose between needle, ball, butterfly, or non-return valves. I will select butterfly valves. For the diameter, you can choose diameter from section. So where we place this valve, it will be diameter from that section, or you can select from catalog. I will use diameter from section. Then you can define position of that valve precisely on exact coordinate, or we can say, okay, it's just a block, some kind of block. So the real position, it's really not important. Of course, it will be in some kind of a manhole or something. So I would say just the fixed distance from node, let's say 5 units in AutoCAD, or in this case 5 meters, which is too much, but it's just a graphical representation. So I will click here on Draw Interactive, and we are talking about node assembly schemes. So we first have to say to which node we are setting something. So to this node, and then the software asks, okay, but on which section? So you can select, for example, just here. I want to place a gate valve just here. So that's it. Or you can select again this node and place it here as well. So we have two valves here. You can continue. For example, my plan is to, okay, not here. So I will click escape and I will click again draw. And I would like to, here they are saved, as you can see. And I would like to place these valves everywhere where I have branching in my network. So let's place two valves here. Let's place two valves here. Okay, let's again go here. I would like to place one here and one here. So it's really easy to define the positions of these valves. And you will see later on when we draw the node schemes, these valves that we define here will automatically appear in this really nice, as we call it, node assembly schemes. And all the valves will be counted into total bill of material. Of course, you don't have to place the valve everywhere, but I like to do it like that. So, and it's quick, so it's no problem to define all these valves where you think that they should go. And here you see the list of all the valves defined. You can also have different types of valves and I don't know, different diameters and so on. Okay, let's close now this, and you can see that these are, like I said, these are some kind of blocks. So these are blocks, okay, and where you can change the visual appearance of this block. So they are on the sections. So if you remember, we have our plan styles, and we are currently using as default my plan style. You can go here and edit this, and this is part of a section. So we are using the real dimensions 2D pipe contours. And here you can see that you have the blocks for valves. So you can define any block here. And you have the blocks for above the ground hydrant and underground hydrant. I will leave the default blocks. Okay, let's now define the hydrants as well. So let's go to function, the same function, draw valves and hydrants. But now from the drop-down list, I will select a fire hydrant. For the type, I will select above the ground hydrant. And for the diameter, now I will not select diameter from section, but I will have a fixed diameter of 80 millimeters. And also you can define a coverage radius, so radius active zone of that hydrant. I will set it to 100 meters. And because I think the position of a hydrant is important, I will not use now this fixed distance. I will use this set position interactively. And now when you click on draw, you can select a node, again, because we are talking about node schemes. You can select a node where you would like to place this fire hydrant. And now you can define the exact position where that fire hydrant should go. And you can see that we have this circle representing this 100 meters that we defined that this is a coverage radius for that fire hydrant. And now I can just interactively pick somewhere, or you can click on a tab on your keyboard, and then you can define the exact distance from a node. Let's say 10 meters on this side from this node. Okay, and now the software will ask you, okay, 10 meters from the node, but on which side of pipeline? Let's say on this side here. And now you can see one fire hydrant is created. We are still in a command, so we can just continue adding new fire hydrants. Let's say from this node, now I will not set it numerically, I will just click, for example, here, and position on the pipe will be go above. Then let's select maybe this one, and let's place it here on this side of a pipeline. Let's go with one more. Let's set it, for example, here, and it will be on this side of a pipeline. Let's do one more row, and let's place more fire hydrants. I will set one here and place it here. So the idea is basically to have all the area covered with this coverage zones with these circles. Okay, let's do one more. Let's place it maybe here. Okay, and let's do one final one, and let's place it maybe like this here. Okay, so the fire hydrants are created. We can check the data about them. So they are all above the ground. We have the fixed diameter of 80 millimeters, and that's it. Let's click close. And you can see that these circles are on a separate layer. So if you don't want to see the circles, you can just turn off these layers. But also I would like to see them, but I would like to increase the line width of them. So let's again go to our system, right mouse button on it, edit. Let's go to layers of the system, and let's find that layer. This is the hydrant coverage zone. It's the cyan color. Let's change a line width from default to 0.3. Okay, and let's click OK. And now you can see how this coverage zone look like, and we see that we have these blocks appearing on the exact side of the pipeline where we defined them to be. Okay, so now that we have, you don't need to set valves and fire hydrants. You can go directly to drawing of the node schemes. But of course, if you previously set valves and hydrants, they will be taken into account for drawing of the node schemes. Before we actually draw something, let's check one more thing, and that is the catalog. So fitting element catalog. You can run it from here and open it here, or you can go to your standard catalog icon, and it's here, catalog of fitting elements symbols. So it's important to say that these are symbols, so symbolic elements. Don't expect this to be some detailed schematic representation with exact dimensions and so on. So these are the, as the name says, node schemes. And these elements are symbolic. But here you can see the catalog. Catalog has been created for ductile iron pipes and plastic pipes, basically, or PEHD pipes. And the elements have been created according to German DIN norm. So here you can see which elements are available. So you see ductile flanged elements, socket elements, and also PEHD elements. And for each item, of course, you can edit these catalogs. You can change the names, you can change diameters, you can give some custom data, for example, like weight of each element, so that will be also calculated when running the total bill of material. You can define nominal pressures or stuff like that. But the thing is that you cannot change how these elements will look like, because it's hard coded. So each of these element has the symbol like it is drawn in the scheme itself. So let's now check this. And again, like I said, you can have multiple configurations, and inside of configuration, you can define many different stuff. As you remember from the previous sessions, we used PEHD pipes. So if we go to the pipes data table, we see that we have PEHD pipes. Okay, so that means that we have to use PEHD configuration. So let's edit it to check what can be set up in the configuration. Of course, you can define the paper width and paper height. I will increase it a little bit to 45. Then you can define some basic visual appearance of the frame. You can define which data will be written here in the title of the scheme. You can define some colors, data, and stuff like that. But what is most important is this. This is the schematic view. So this part of the drawing. You can define the colors. I will change. So the fittings will be drawn in blue color, and pipes between the fittings by default are in yellow. But I will switch to orange so we can see it a bit better on a white background. Also, for the labels, you can choose if you want to see just the position in the scheme of the element. You can define if you want to see position and the name from the catalog, or just the name. Okay, and also this is maybe the most important thing, is select the elements from the catalog. Because even though in the catalog you can have basically all the fittings available in the world, or which are by default in Urbano catalog, but still maybe your local manufacturer don't have these parts, or you are not you are not usually using that part. So you can just filter those parts out. For example, here you can see in this configuration we have PEHD pipes, and only angles will be used 45 and 90. Here you see 11, 25, 22.5, 30, 45, 90. But here you see just 11.25, 22.5, 45, and 90. So it depends on your wishes. So let's check here. This is filter, just filter of the catalog. So let's filter PEHD catalog, and let's check only angle elements. And here you can turn on or off different parts from the catalog. For example, here you can see, like I said, we have only Q90 elements and K45 elements. But angles of 30, 22.5, 11, 25 are turned off. That's how it is set inside of this configuration. But for example, let's copy this configuration. I would like to have this, but let's copy this one. It's always better to copy something, that's just my opinion, and edit it, then create new from scratch. So I will edit this. I will give it a name 5 PEHD, and I will say all angles. Okay, let's edit it. Let's go to schematic view, select elements, PEHD, angle parts, and here I will select the first one, I will select the last one, and I will turn on all angles. So as you can see, here is the filter. So we'll have Q90, K60, K45, K30, K22.5, and K1125. Let's click OK. What else can be changed here? So you will see that these node schemes will be completely drawn, completely automatic based on some rules. And here are the rules that you can change. For example, what is the material? PEHD or ductile? This is basically just a matter of diameters that you have in your pipe catalogs, because for example in PEHD pipes you have diameters of, let's say, 125, 125, 140, 160, 180, usually 200, 225, and so on. But for ductile iron pipes you have 80, 100, 150, 200, 250, 300, and so on. So that's why you have this, what is the material. Then you can define, for PEHD it's grayed out, but if it's a ductile, you can define to use socket elements or strictly just flange elements. You can define to use single or double socket elements. Then you can define for ductile and for PEHD how to connect a fire hydrant with which parts. Then, for example, you can choose if the T element will be aligned with the inlet section, or it will be rotated so that you have the minimum amount of pieces needed. Then you can choose to have T elements integrated with reduction, or if you turn it off, you will have the T piece without reduction and then additional reduction piece. You can choose to use double T piece, so cross piece, or twice the T piece. You can choose if you want to put reduction, if possible, before the crossing or always after the crossing. And also you can define some visual appearance of the scheme itself. Okay, let's click OK. And also for the bill of materials, you can define which data you would like to see in the bill of materials. So by default, it is position, type, nominal diameter, material, and quantity. You can also add the weight of the elements, but then you have to put your own custom weights in the catalog because by default they are empty. Okay, and okay. That's it. Now we have everything ready to actually draw something. So for example, let's first use this one, PEHD 45 and 90 angles only. So select it. And basically now everything is ready. You have your selection options. Let's select the entire system. You can define the row spacing and the column spacing. We can click on draw. Let's place it here. And that's it. With just one click of a mouse, we have all the node schemes calculated and drawn according to rules and the parts available in the catalog. So you can see that the software can now use only angles of 45 and 90. So it's always using the closest possible angle. So these are the simple ones. These are the ones with the valves. You can also see the reductions. And like I said, these elements, you cannot change the visual appearance of them. You can change the scale, you can change the color, but this is the style, the default hard-coded style for the PEHD pipes. This is the connection of the fire hydrant, and so on, so on. And you can see that each scheme has the total bill of materials. So positions written in the labels, what is the type of element, nominal diameter, material, and total quantity of the elements used to solve one node. Okay, so these are the PEHD pipes with only angles 45 and 90. But let's now check these all angles. Let's double click on it. Let's select everything and let's click draw. And you will see that when you redraw something, the old ones will automatically disappear because one node can have only one solution. You cannot have multiple solutions for the same node. So when you click draw, the old ones will disappear and the new ones will appear. And now you see that we are using all angles here. So here you can see that now we have here the angle of 1125. So, but these are maybe angles more often used for the ductile iron pipes, but it's up to you to define which angles will be available in your configuration. So now you can see that the angles are much more precise, but also they are used again, like I said, to so combination of these angles, so they are as close as possible to the real angle from the plan. Okay, and if you need the total bill of material for all of the elements used, you can go to right mouse button, manage of the node schemes. Here in the list, you can select all schemes and you can click here, total bill of material, and I will place it here, for example, and that's it. You see for the entire system, PEHD elements, you see what are the types, nominal diameters, so everything is sorted by nominal diameters, materials, and total quantity of elements used to solve this entire system. And this is the plain AutoCAD table. So if you want to export this to Excel, you can just go to export and export the table to CSV file that can be opened in Excel. So this is the default style for the PEHD pipes. So let's now show the same, but for ductile iron pipes. So I will open another drawing, which is basically this same drawing, but with different pipe diameters. So you can see again, all the fire hydrants are defined. We can see these fire hydrant coverage zones. And also if we zoom in a bit, you can see that the diameters are now different. So you can see the classic diameters for the ductile iron pipes. We can check that as well if we open the data table for ductile iron. And here you can see the diameters and the material. So if we have ductile iron pipes, we have to use a configuration for ductile iron. And here you can see you have ductile with sockets with these angles, ductile with double sockets, and ductile with flanges only. So let's check it. Let's double click on a ductile socket. Let's select everything and let's click draw. Let's place it here. And this is a default style for ductile iron pipes. So you can see this is the standard pieces from the catalog for ductile iron pipes. So MQ, MK, and so on. So this is the knee pieces, combination of knee pieces for larger angles. And here you can see the branching with the T-piece. These are the reductions. So reduction before the T-piece, if possible. Here are the valves. Here are again the knee or the curved angle elements. So that's how you can use this for the ductile iron pipes. And here you can see connection of the fire hydrant. And as you can see, this configuration is ductile with sockets. And also notice this is the single sockets, but you can also switch to ductile with double socket elements. And now when we click on draw, let's place it again, you will see that everywhere it will be used with the double socket elements. Of course, you don't have to apply one configuration to the whole drawing. You can apply different configuration to different nodes and have different types of elements. And also, let's check the last configuration, ductile with only flange elements with all the angles. Let's select everything. Let's click on draw. Let's place it here. And now you will see that again, it looks completely different. This is maybe better style, better solution to use if this is happening inside of a manhole, because you have this entering piece inside of the manhole, then you have the reduction, the classic T-piece, the valves inside, the reductions, and then the parts where you are exiting of the manhole. And again, you have all all the pieces that are calculated in the bill of material, so you can also calculate the total bill of material. Okay, the style that I like to use the most is this one, the first one with the sockets. So I will apply that one here. And let's also create the total bill of material for the ductile iron pipes. Let's go to manage of the node schemes. Let's select everything. Let's click here on a total bill of materials and let's place it here. And now you can see different types of elements, nominal diameters, materials, and quantity.